Okay, time to start, right? Okay, hello everybody. You are welcome to today's class. Today is a special day because we're going to be continuing from the series that we started last week. Okay, and that is electron emission. Last week we saw the different types of electron emission. And this week we are going to be looking at another type of electron emission, which is what we call photoelectric emission. Okay, so we are looking at photoelectric effect or photoelectric emission. Now, if you are here, you can just comment. Say, yes sir, I can hear you. Okay, you can just comment. If you are here, you can just... Okay. So, now photoelectric effect. Photoelectric effect is, like we mentioned the last time, is the process whereby electrons are emitted from the surface of a metal when electromagnetic energy of sufficient light falls on it. Now, electromagnetic energy of sufficient light falls on it. Now, of sufficient energy. So, already when you have a metal surface and photon energy, or what you call light energy, or any of the electromagnetic energy, falls on the metal surface, just like we have here. Now the result of that is that electrons will be emitted, and that is what we call photoelectric effect. Now there are certain conditions for photoelectric effect to occur. There are conditions for photoelectric effect to occur. Number one is that is what we call the threshold frequency. Let me start with that. We call it the threshold frequency. Okay? Now, this threshold frequency is the minimum frequency that a light must have before it can eject electrons from the surface of a metal. We call that threshold frequency. So, you can put in bracket the minimum frequency for ejection. Okay, so that is that. So the light must have a threshold frequency. Now, number two, the second condition for electrons to be ejected is that the energy must be sufficient energy. Sufficient energy. Now, this sufficient energy is what we call work function. We call it work function, and the symbol is simply this, phi. We call it phi. So just a circle, then this in between. Okay, so that is the second condition that must be met before electrons can be ejected from the surface of a metal. Now, the third condition, number three, is that the metal itself has to be suitable. So I will call that suitable metal. The metal must also be suitable. That means, now when we say suitable metal, meaning that the metal must be such that it can easily emit electrons, or the metal must have a low work function. Because the work function is actually a characteristic of metal. It's one of the every metal has its work function. So in order to use photoelectric effect, or for photoelectric effect to be very, very useful and very effective, then you must use a metal that has a very low work function. That means the metal must be such that when light falls on it, electrons are easily emitted. So these are the conditions for electrons to be emitted from the surface of a metal. The first one is that the light falling on the metal must have a minimum frequency, and that minimum frequency is what we call threshold frequency. Then secondly, that the light must also have sufficient energy. Okay, the energy must be sufficient and must be equal to the work function. The energy of the light must be either greater than, okay, let me put it this way. Let's assume that the energy of the light is E, the energy of the light that falls on it. Now, if the energy of the light is less than the work function of the metal, there will be no emission or ejection. So there will be no emission or ejection. Now, if the energy of the light is equal to the work function, remember I said that every metal has a work function. Okay? If the energy of light is equal to the work function, there will only be ejection. I call that ejection. Ejection simply means that the electrons can shift. Okay? Now, but if the energy of the incident light is now greater than the work function, okay, this is where we now have electron emission. So when the energy of light is greater than the work function, that is when we now have electron emission. Okay, so electron emission simply means that the electron now gains speed. When it was equal, what we had was ejection. That means electron can only be enough to shift from the surface of the metal. But when it is greater than the work function, what we now have is emission of electron. That means that electron not only shifts, but it will gain kinetic energy. That means it will gain speed. So the only time electrons can gain speed from the surface of a metal is when the energy of the light falling on the metal is greater than the work function of the metal. Okay, but don't forget that these are the conditions. The light must have a minimum frequency, which we call threshold frequency, and it must have sufficient energy, which we call work function. The sufficient energy must be equal to the work function. Then thirdly is that the metal must be a suitable metal. Then the metal must have a low work function, for it to be very useful. I hope that makes sense. Okay, and I will appreciate it if you comment to show that you are following with what we are doing. Okay, so that now leads us to, okay, I think I will give you just a few seconds to write this down before I continue. Okay, so this now leads us to the next thing, which is properties of photoelectric effect. Certain things that you should know about photoelectric effect. So kindly note. Okay, the first property is that number one, there is no emission below the threshold. Sorry, I think my stuff is wet. There is no emission below the threshold frequency. Okay, I already mentioned that there is no emission below the threshold frequency. Then secondly, you should note that the emission is instantaneous. Emission is instantaneous. That means once light hits the surface of the metal, emission is very instantaneous. Okay? Now, another thing I want to also mention is that the number of emitted electrons, now this is very important, the number of emitted electrons is proportional to the intensity. This is an exam question, please, of light. Proportional to the intensity of light. So let me say this before I move forward. no matter how intense light is, it is not enough to eject electrons from the surface of a metal, no matter how intense. So intensity of light has nothing to do with ejection of electron from the surface. The light must have minimum energy, which is equal to the work function, for electrons to be emitted from the surface. But when we talk about the number of electrons emitted, intensity can make that happen. Work function will emit the electrons. Energy of light will emit the electrons, but the intensity of light is what will make the number of electrons emitted to be more. There will be plenty, enough, number of electrons emitted. Now that is very, very important for us to note. Okay? Now the next thing I want you to also note is that number 4, the fourth property of photoelectric effect is that the speed or kinetic energy of the photoelectrons increases with increase in frequency. Okay? Increases with increase in frequency. Now this is very, very important. So the speed of a photoelectron, well, I didn't mention something about photoelectrons. Any electron that is emitted because of photoelectric effect are called photoelectrons. Okay? So you will hear me say photoelectrons. That's exactly what that means. Now the speed or kinetic energy of the photoelectrons increases with increase in frequency. That means they are proportional. So the higher the frequency, the higher the speed of electrons. Or you can say the higher the frequency, the higher the kinetic energy of electrons. I hope that makes sense. Okay, now another thing I want to say is that each metal has a unique work function. Each metal has a unique work function, which is this. Every metal has its own work function, and every metal also has its threshold frequency. Okay, that's very important for you to note. Now the symbol of threshold frequency is F0, and the symbol of work function is this, phi. Please don't forget. Later I'm going to show you the relationship. Then another, okay, I think that is it. These are the 5 properties of photoelectric effect you should remember. Number 1, there is no emission below threshold frequency. Or you can even say there is no emission below work function. Number 2, electron emission is instantaneous. That means once light falls on the metal surface, electrons will be emitted. Now number 3, the number of emitted electrons is proportional to the intensity of light. Remember I said that intensity of light has nothing to do with ejection, but if the intensity is more, the number of electrons that will be ejected will be more. If the intensity is less, the number of electrons that will be emitted will be less. Then the speed or kinetic energy of the photoelectrons increases with increase in frequency. I already mentioned that. So if I want the electron to gain more speed or to gain more kinetic energy, they are related. All I need to do is to increase the frequency. Then every metal has a unique work function. Every metal has a unique threshold frequency. Okay, so I will give you just few seconds to write this, then we continue with the next. And if you have questions, you can drop them on my phone so I can respond immediately. Okay, I'm about to rub off. Let's see. Okay, so now that leads us to the definition, or will I say the formulas for each of these terms we mentioned. First of all, I'm going to mention is the work function. Now the formula for work function is equal to hf naught. The h here is what we call the Planck's constant. We call it the Planck constant. Is a constant value, okay, of 6.63 times 10 to the power minus 34 joule seconds. That's the formula for Planck constant. And the F naught here, like you already know, is called the threshold frequency. Okay? Now, I would like to also say this, that okay, somebody's asking, what do I mean by no emission below the threshold frequency? Now, what we are saying, what I mean is that, remember, if maybe, let's say the threshold frequency is 2 Hz, for example, if the frequency of the light that falls on the metal is just 1 Hz, that means emission will not occur because it's lower than the threshold frequency. Emission is not going to occur. That means for emission to occur, it must be equal to the threshold frequency or greater than the threshold frequency. I hope that explains that. Okay, so we have this, you have your H to be this, you have your F naught. Then this formula, I can also write it as HC over lambda naught. Now, because frequency is always speed over wavelength. It's a general formula, one of the formula for waves, properties of wave. Frequency is speed over wavelength. So this lambda naught here, I'm going to call it the threshold wavelength. We call it the threshold wavelength. Then C, of course, is the speed of light. Now, either you say speed of light or any of the electromagnetic waves. It can be speed of light, it can be speed of electromagnetic waves. Okay. So this formula is very, very important. Of course, we are going to be seeing questions, relating this. Now, the second thing I want to mention is E, the energy of the incident light. Okay. Now, the energy of the incident light is equal to HF. The same formula with work function. But the difference is that in work function, you need threshold frequency. But the energy of the incident light is, you just need normal frequency, which must be equal to this or greater than this for electron emission to occur. Okay? Now, I can still write this as HC over lambda. This is true. So my E here is going to be called energy of incident light. Okay, my C here is going to be called speed of light. Okay, I already mentioned that earlier. Speed of light is this. Then this is going to be wavelength of incident light. Now let me also say this, that this energy of incident light can also be called photon energy. So sometimes you're going to be seeing me interchange photon and light. Photon also. So when I say light energy, I can also say photon energy. The energy of the light that falls on the metal. So I have given you two things here. Now the first one is the work function. Then the second one is the energy of the incident light. Now we want to find the relationship. Already, this is the formula for the work function, H times F naught. This is the formula for the energy of incident light, H times F, or you say HC over lambda. But now, there is a relationship between this and the work function. Now, remember I said earlier, and I'm going to repeat myself again, that if the energy of the incident light is less than the work function, there will be no emission. No emission at all. Nothing will happen because it's not enough to cause an emission. If the energy of the incident light is equal to the work function, then there will be ejection. Ejection simply means that the energy is sufficient to shift it. is sufficient to move it. Okay? Now, I know some of my students are going to laugh at this. I'm going to use the example of a man that is wooing a woman. Okay? So, the man must have a minimum vibe to make the woman consider. So that minimum vibe, in this case, is what we call work function. Right? Now, if a person comes and the vibe of that person is not up to the work function, the woman will not even think about it. As a matter of fact, touching the girl will make the girl more angry. Some of you know what I'm talking about. Now, but if the vibe is equal to the work function, it can make the person think about it, but maybe nothing. But if the vibe is greater than the work function, oh my goodness, there's going to be plenty emission of electrons. There's going to be joy everywhere. You're going to be smiling like a fool everywhere. You understand that? Okay, so that's exactly what we are saying here. When the energy of incident light is equal to the work function, there will just be an ejection. That means it's enough to just shift the electron. But if the energy of the incident light now, E, is greater than the work function, if it is greater now, there will be emission. And the more the energy, the more the emission. The more the energy, it will gain kinetic energy. So let me say this, that the energy of the incident light by formula is equal to the work function plus the kinetic energy of electrons. This balances it. That means if the energy of light is greater than the work function, this, okay, is enough to eject the electron. But if it is greater, the remaining energy will now be converted to kinetic energy. That means the electron is going to gain speed. The electron is going to gain speed. Okay? So this is the formula relating them. This. Okay? So if you like, you can substitute their formulas. You can say HF is equal to HF naught, then plus kinetic energy. I hope that makes sense. Okay. So I want to talk a little more, but let me allow you write this, process this. If you have any question, I will be waiting. Okay. I hope it is making sense. If you have a question, you can answer. I'm about to clean the board, but I want you to process it a bit. You know, I'm looking and watching out for questions. Okay, I can see no question is coming, so I'm going straight to the next thing. Like I said, you can always watch the video. I will leave it for 72 hours maximum, then bring it down. Okay? Okay, so I want to talk a little about the kinetic energy. Like I said, when the energy of the light that falls on the metal is greater than the work function, the remaining, the extra, is converted to kinetic energy. Okay? And so, what is the kinetic energy? Very simple. Kinetic energy is simply the difference between the energy of the light and the work function. Just chicken, right? So I can say that kinetic energy, Ke, is going to be the energy of the incident light minus the work function. As simple as that. I can write it as, this one now is written as HF, is the same thing. And why this is written as HF naught, the same thing. If I like, I can factorize H is common. I can factorize H, then we have F minus F naught left. You know, you can just do a lot of manipulations here, You know, we can even manipulate further, but I don't want to bore you with that. Okay? All you should know for now is that the kinetic energy is the difference between the energy of the incident light and the work function. Okay. Okay, I'm seeing your comments, and I appreciate your comments, you know, so that I can be sure that you are all following me. So that leads us to the next thing. And that next thing is what we call, well, the same kinetic energy. I want to say some extra things about kinetic energy of photoelectrons. Now, another thing you should note about kinetic energy, just like many of us know, that kinetic energy can also be written as half mv squared. This is the general formula we know for the energy of electrons. And I just remembered something. This kinetic energy is also called energy of electrons. In case you see a question, energy of electrons, and but you know, energy of incident light, we call that energy of photon. Don't forget that. I also want to say something, that in the real sense, the energy of electron is actually measured in what we call electron volts. That means E times V naught. Very, very important. E here represents the charge of an electron. The charge of electron. And the charge of electron is constant. The charge of electron is 1.6 times 10 to the power minus 19 coulombs. That's the formula for charge of an electron. Then this V naught here, we call it stopping potential. There's something I'm going to mention, but we're going to get to that. So kinetic energy is electron volts, or E times V naught. E here stands for charge of electron. This one is constant. It has a constant value. Electron charge has a constant value of 1.6 times 10 to the power minus 19 coulombs. Then the stopping potential, V naught here stands for stopping potential. The unit can be anything. It is measured in volts, you know, capital V. So I want to give you time. I'm about to define what stopping potential is. Very important. Okay, I appreciate everybody writing. You know, your comments is helping me, you know that you are following. Now, the next thing I like to talk about here is what we call stopping potential. Now, there are two things I'm going to say about stopping potential. Number one is that stopping potential helps us to measure the maximum kinetic energy. It helps to measure the maximum kinetic energy. So the maximum kinetic energy of an electron, of a photoelectron, is measured by what we call stopping potential. That means this formula we write here, I will be correct if I call this Ke maximum. That means the maximum kinetic energy an electron will possess. Okay? Then secondly, I would like to say this, that stopping potential is the minimum voltage. Stopping potential is the minimum voltage, okay, that can stop a moving photoelectron. That can stop a moving photoelectron, okay? If you like, you can add to get to a collector. Okay, so that is very, very important. So stopping potential is the minimum voltage that can stop a moving photoelectron to get to a collector. Yes. So, and stopping potential is also very, very important. As we continue, we are going to see more things about stopping potential. So the next I want to talk about, very, 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 very important, is calculations. Let us see some calculations. We are going to be done with this soon. We have about, let's say, 25 minutes, right? So let's see some calculations. But I'm going to give you a few seconds to write what we have on the board for those writing. And like I said, this is going to be after maximum 72 hours, I'll be taking it down. So you have at least within 72 hours to go through the videos again. It could help you. Okay. And like I said, I'm seeing your comments. So if you have questions, you can put them there. Okay, trying to get questions. Okay, I'm trying to respond to some persons that are looking for the link of the class. Okay, so I want to quickly send the link to the class before I continue with questions. So just give me a few minutes or a few seconds, please. Okay, so let us see some questions. So I'm going to be starting with easy questions, then, move on, we keep going higher. So I clean this up. Okay, the first question here. Okay, this is it, and usually so look at this straightforward question. It says the threshold frequency of zinc is a metal, is 9.6 times 10 to the power 14. We are now asked to find, it says, what is the work function in electron volts. Okay, before I answer this question, I like to say to you that work function, both work function, energy of incident light, and kinetic energy, their units are all in joules. Capital J, joules. Okay? Now, but they can also be measured in electron volts. That is another unit, electron volts. So, kinetic energy of electrons, work function can be measured in joules and can also be measured in electron volts. And this is the relationship between joules and electron volts. 1 electron volt is equal to 1.6 times 10 to the power minus 19. Okay, 1.6 times 10 to the power minus 19. Yeah, the number there is my WhatsApp number. Yes, you can chat me on my WhatsApp number. Yes, you can. Okay, so now watch this. The threshold frequency of zinc is this. What I do in solving physics questions, especially calculation, is that I state all the quantities that are available in the question. That will help me know which formula to apply. So it says, the threshold frequency of zinc is this, 9.6 times 10 to the power 14. And so I'm going to say F naught, that's the formula symbol for threshold frequency, is equal to 9.6 times 10 raised to the power 14 hertz. Okay, that's the formula for threshold the symbol for threshold frequency, 9.6 times 10 to the power 14 hertz. Now it now says that the work function, what is the work function in electron volts? That's all. So we are looking for the work function. So this is what we are asked to find, work function, and all that we are given is threshold frequency. And I think based on this question, we have all information we need. Because if you remember what the formulas I gave you earlier, that work function is simply equal to the Planck's constant. This is called the Planck's constant times the threshold frequency. A very straightforward question. I know many of you will be praying, let my question be like this. You know, but whatever. This is what it is. Now, the H here is 6.63 times 10 to the power minus 34. Then the threshold frequency is 9.6 times 10 raised to the power 14. So my Planck's constant is 6.63 times 10 to the power minus 34. Then the threshold frequency is 9.6 times 10 raised to the power 14. Okay, so if you have a calculator, you can do that quickly. I think I have my value here. You can tell me what your answer is, whatever. But I think my answer here is 6.36 times 10 to the power minus 19 joules. Yeah, that's my value. That's my answer, 6.63 times 10 to the power minus 19 joules. Now, but if you leave your answers like this, you have not answered the question correctly, because the unit here is joules. The question says, what is the work function in electron volts? That means I need to change these joules to electron volts. And the only way I can achieve this is to divide this by this formula, this value here, 1.6 times 10 to the power minus 19 joules. Okay, so we are going to come here and say this is now equal to 6.63 times 10 to the power minus 19 over 1.6 times 10 to the power minus 19 electron volts. And if you divide this, you are going to get 3.98 electron volts. Wow, this is beautiful. This is quite easy. So we apply the formula for work function. Then we substitute the value. Planck's constant is a constant value. Usually it's given, but even if it is not given, you should know it. You're a science student. Then you have the threshold frequency, which will always be given in the question. And if you multiply these two, you're going to get this value in joules. The formula is in joules, but you can convert it. So you can convert it to electron volts, and we have these questions. Now, I like to say this, that I'm going to be solving minimum questions here, but on our WhatsApp group, the general WhatsApp group for these classes, we are going to be posting more questions. We will continue the practice on WhatsApp group, you know, for those of you that join the WhatsApp group. So my phone number is there. You can just chat me up to send you the link. And you can also share this, you know, to your friends. Please make sure that your friends, your family, they are connected to this, because it's going to help a lot of people. The reason why I am doing this is because I know that it is very scarce to get very good teachers out there. Many people, they have the resources, but they don't really have the human resource to help them understand some of these things. So I want to use this opportunity to stand in that gap. So please involve everybody, send the messages, share, you know, and I will say, let me say, God bless you. Okay, so I want us to see another question very quickly. Yeah, for those asking if you can chat me, yes, you can chat me. For those saying well done, thank you. So I'm about to clean this up now. Okay, so let's see some more questions. And maybe I'm going to write them all out so that we can go straight to the point. Okay. Okay, this is a bit tough. Another question. Let me get a different marker. Okay, let me add one more. Okay, we have these 3 questions. I think we are just going to be doing these 3 questions and we call it a day. Okay, sorry, I'm sorry, my board is full, right? We're going to go with each and every one of them. Let's start with the first one. But I think I should give you 5 to 10 seconds for you to go through this. Okay, so hopefully we can do this in 10 minutes. Now, number 2 question says, radiation of frequency 8.0 times 10 raised to the power 14 hertz. So radiation of frequency this. So this is the frequency of the light, not threshold. If it was threshold, they will state it there. So we are going to say here that the frequency F is 8.0 times 10 raised to the power 14 hertz. Strikes a metal. You can see that's the incident light that strikes the metal with a work function of this. So the work function of the metal is this. Is equal to 2.0 electron volts. Now I want you to notice something. The work function here is given in electron volts. So take notes. Now we are asked to calculate the maximum kinetic energy of electrons. This is very simple. I already told us what maximum kinetic energy of electron is. Since we are given the work function and we are given the energy of the incident light, we can say that the maximum kinetic energy is equal to the energy of the incident light, the difference between the energy of the incident light and the work function. I gave this earlier when we started. So the question now is, what is the energy of the incident light? Then also, secondly, what is the work function? I believe this is quite clear. Okay? Now, how do we find energy of the incident light? It's not given, but we are given frequency, so we can find it. So I can say that energy of incident light is equal to HF. That's the formula for energy of incident light. That means 6.63 times 10 to the power minus 34 multiplied by the frequency is 8.0 times 10 raised to the power 14. So you can use your calculator to get that. Let me see if I have a calculator here. Of course, you should expect Lifechanger to have calculator. Okay, so this is 5.3 approximately times 10 raised to the power minus 19 joules. Okay, that's important. So this is in joules. Remember, this formula is in joules. Then secondly, what a work function? If you notice here, the work function is already in electron volts, and that's a problem. We need to also convert it. So how do you convert electron volts to joules? You multiply by 1.6 times 10 to the power minus 19. So I'm going to say here that my work function is electron volts. That means 2.0 electron volts, which means 2.0 times 1.6 times 10 to the power minus 19 joules. That's how you convert electron volt to joules. And with that, this is going to give us 3.2 times 10 to the power minus 19 joules. So the work function is 3.2 times 10 to the power minus 19 joules. Now it's very easy to find the kinetic energy. So my kinetic energy now, maximum kinetic energy is energy minus the work function. The energy is 5.3 times 10 to the power minus 19. minus the work function is 3.2 times 10 to the power minus 19. Okay, so that's what we have there. Now, if you subtract this, this is going to give us, now let me say this, whenever you have standard form, all you need to subtract is make sure that the standard form is the same. This is 10 to the power minus 19, this is 10 to the power minus 19, you will keep that constant. Please note, that's how you add standard form. You keep that constant, then you now subtract 5.3 minus 3.2. This will give us 2.1. So this is the final answer, 2.1 times 10 raised to the power minus 19 joules. So we can say that the maximum kinetic energy of electrons is 2.1 times 10 to the power minus 19 joules. Very easy. I would also like to add here, I know you are writing, that this value, if you like, you can convert it to electron volts. If you want to convert joules to electron volts, remember you divide by 1.6 times 10 to the power minus 19. Okay, you can write that. Okay, I want to say here the easiest way for you to reach me on the classes, for you not to miss the classes. I noticed some persons are asking me for the link. Just follow me on Facebook, so that whenever I'm live, you would have the notification. Okay, that is very important. Okay, so this is what we have. If you have any question, you can put it, but if there are no questions, no problem. We can continue on the group, on the WhatsApp group. And it's free. The class are free, the WhatsApp group is free. So, you know, just a way of giving back. Okay. I should write this. Okay, so let's see the next question. The next question, number 3, says, you can always go through this, you know, like I said. The stopping potential for photoelectrons emitted from the surface is 1.5 volts. Find the maximum kinetic energy of electrons. I think this is the easiest kind of question you can always see. These are the kind of questions you should pray for. So this, and I'm going to show you one trick also, very important. Now stopping potential is V0, is 1.5 volts. That's what we are given. And we are asked to find the kinetic energy of electrons. Now, this is especially for those of you writing JAMB and also WAEC in your objective questions. Please note this. With this, I can just simply say that the kinetic energy of electrons is equal to 1.5 electron volts, and I'm done. All you just need to put is the value of this electron. So, if the stopping potential, let's say, is equal to 3 volts, it means that the kinetic energy is going to be 3 electron volts. Just insert electron. I think I deserve a bottle of Coke from you for that. So 1.5 electron volts. But except if you are asked to leave your answer in joules. But if your answer is to be left in electron volt, this is this. And in the same way, if you are given kinetic energy, you can find stopping potential. If kinetic energy is 1.5 electron volts, it means that stopping potential will be 1.5 volts. Just remove the E. As simple as that. So this is the answer to this question, 1.5 electron volts. Except if the option is in joules. Then you can now say, if I want to convert this to joules, I'm going to say 1.5 times 1.6 times 10 to the power minus 19 joules. 1.5 times 1.6 times 10 to the power minus 19 joules. And that would give you the answer. I think this is 8. Okay, I think this will give us 2.4 times 10 to the power minus 19 joules. Now remember, you don't have to do this except if you are asked to leave your answer in joules. This is already the answer, but this is in electron volts, and why this is the answer in joules. I mentioned that kinetic energy can be measured in joules. It can also be measured in electron volts. Okay. Okay. Wow, this is getting interesting, right? So I give you 5 seconds to write this. I mean, few seconds to write this. Okay, so that leads us to the last one. Our time is up, but I guess we should finish the last one. Okay, so this one says light of wavelength, this here we are given wavelength 400 nanometer, falls on a metal . Okay, somebody's asking, we did 6 times 10 raised to the power 10. Okay, where did 6 times 10 raised to the power 6 times 10 come from? Oh, I wish I saw that earlier. Where did we have 6 times 10? Okay, if you write it in full, I will get that. I can't remember where we got that. Okay, so light of wavelength 400 nanometer falls on a metal with work function this. Find the maximum kinetic energy of ejected electrons. Okay, very easy. I'm giving wavelength of this. This is the wavelength of the light. This is 400 nanometers. Now I want to say this, don't forget that the nano here is 10 raised to the power 9. Actually 10 to the power negative 9, minus 9. So I can write this as 400 times 10 raised to the power minus 9 meters. Nano here is 10 raised to the power minus 9. So I can leave it this way, or I can use my calculator to multiply this to become 4 times 10 raised to the power minus 7 meters. Okay, we can do this too. For the person that asked the question, if it is about 6.63 times 10 raised to the power minus 34, this is a constant. It's called the Planck's constant. I already mentioned that. Okay. So now the question now says falls on a metal with work function this. The same thing. The work function of the metal is 1.8 electron volts. It's given in electron volts. Find the maximum kinetic energy. This looks like the question we did before. Very straightforward. Kinetic energy is equal to energy of light minus the work function. So all I need to do is to find the energy of light, then also find the work function, and I subtract it. So my energy of light, since I'm given wavelength here, I'm going to use the formula hc over lambda to find the energy of light. Straightforward. Now remember, the formula is supposed to be hf. But the reason why I'm not using f is because they did not give me frequency. What they gave us was wavelength. So in that case, I just say hc over lambda. Okay? So the value of h is constant. 6.63 times 10 raised to the power minus 34. The value of c is also constant. Speed of light is the same value. That is 3 times 10 to the power 8 is a constant value. Then your wavelength is what is given in the question, which is 4 times 10 raised to the power minus 7 meters. Let's calculate that if you have your calculator. Let me use my calculator. Okay, what I got here is 4.97 times 10 raised to the power minus 19 joules. 4.97 times 10 to the power minus 19 joules. That's what we get for this. Okay, then the next thing is to find the work function. Work function here is given in electron volts. We need to change that. Remember, since this is in joules, it must be consistent. So I'm going to say that work function is 1.8 times 1.8 electron volts. Now I multiply by 1.6 times 10 to the power minus 19. So this is 2.88 times 10 to the power minus 19 joules. Straightforward, right? Then if we are now to find our kinetic energy, energy of incident light minus work function, the energy of incident light is 4.97 times 10 raised to the power minus 19, then minus 2.88 times 10 to the power minus 19. I already taught you what to do here. Pick one. That means times 10 to the power minus 19. Just pick one. As long as they are the same, pick one. Then subtract this. So 4.97 minus 2.88 is going to give us 2.09 times 10 to the power minus 7 joules. So this is the answer. The kinetic energy of the electrons is 2.09 times 10 to the power minus 19 joules. Or you divide to convert it to electron volts. You divide it by, or you can say 2.09 times 10 to the power minus 19 divided by 1.6 times 10 to the power minus 19, and that will help you convert that to joules, to electron volts. So this is equal to 1.3. So this should be it for today because of our time. But I'm going to give you a few seconds. In case you have questions, you can ask. And I'll be willing to answer this. So while you're writing, I want to remind you, make sure you belong to the general WhatsApp group where we will continue with questions on this. Remember, practice makes perfect. So I'll be posting a lot of questions there, and you try, we post solutions and all of that, and we will continue from there next week. Now in next week's class, I'm going to continue with X-rays. This topic is a very important topic. All of these things I'm teaching, very, very important. I am not done with photoelectric. We are supposed to see applications of photoelectric effect, but we will do that on the group. Okay? And maybe the graphs too, we will do that on the group, and all of that. We'll continue on the group. But the majority, the most important thing that you should know are the things that we have treated here this evening. I want to thank you So far, I don't think I have any questions coming on. So I want to thank every one of you that took out time to join this class. I hope you know that the sky will be your limit. Okay? Thank you very much. And also, I want to also say this. If you need me to treat any topic, you can always post it on the group. You know, I will plan towards that so that, you know, I can help you become strong, make your feet strong in preparation for your exams. So, thank you very much. I'm going to stop here. I wish you the best. See you next week. Thank you. Bye. And don't forget, this is somebody's asking if I have the JAMB syllabus. Yes, you can always chat me up for that one. I can give you the JAMB syllabus. So thank you very much. I wish you the best. We are going to continue on the WhatsApp group. And don't forget, this is Lifechanger Academy. Share. You know, make sure you talk to friends about it, talk to family about it. This is a revolution. This is the first time something like this will be happening. I don't know why I'm doing it, but I believe that it is going to help a lot of people. So talk to as many persons as possible, share the link to people, follow me so that you can always get notifications whenever we come online, and we are good. Thank you very much. My WhatsApp number is on the status. Is there. You can copy the WhatsApp number, send me a message, ask me your questions, and we will continue from there. Thank you very much. I also want to mention, sorry, before I forget, for those of you that are interested in my 30 days boost, you know, we are starting tomorrow all through to exams. You can start chatting me up and start paying up, you know, and we'll see how far that can lead us. Thank you very much. Bye-bye.